Hello and welcome to this online practical introduction to BPSim. My name is Emmanuel and I will present you what BPSim is and how to use it. Before we begin, this tutorial is addressed to people having a good knowledge of BPMN, as BPSim and BPMN are strongly related to each other. If you're not familiar with BPMN, we invite you to watch our introduction to BPMN video first. BPSim stands for Business Process Simulation. It has been standardized by the WFMC, Workflow Management Coalition. It allows business process models captured in BPMN to be augmented with information for performance analysis. To understand what BPSim can be used for, let's take the example of a pizza delivery process. The process can be described with BPMN. It describes who is doing what and when. The clerk answers the phone, takes the order, passes it on to the cook, who prepares the pizza. When the pizza is cooked, it is handed to the delivery boy, and so on. BPSim will allow to add time and cost information to each task in the process. For example, it takes 3 minutes to bake the pizza. To define the required resources for each task in the process. For example, an oven is required to bake the pizza. To define a scenario. How do we handle 50 pizza orders in 15 minutes during the next Soccer World Cup halftime? As a result, it is possible to evaluate with a given set of resources, people and machines, the average lead time for one pizza order and the quality assessment based on an expected delivery time. Okay, let's dig into it now. First, the overall organization of BPSim. The top-level container of the information is the scenario. Each scenario contains a number of details. The scenario has a name, a description, a version, an author, a creation date, a modification date, a duration, a start date, a number of replication, a seed to draw the statistical values, a base time unit, and a base currency unit. What we will discuss from now on is always in the context of a specific scenario. For each element, a number of parameters can be set. Time parameters, cost parameters, resource parameters, and control parameters. Each one of these parameters has a value that can either be a constant or a distribution. When based on a distribution, a number of statistical laws are listed in the standards, such as triangular, normal, Poisson, and so on. Now, the values may follow a calendar that specifies when the value is valid. It is the valid for attribute that follows the RFC 5545 iCalendar notation. Let's now go through the different parameters that can be associated to an element. We will start with the time parameters, which are valid only on atomic activities. Time is decomposed in 7 parts and 3 groups. First, the overall time between 2 activities is the elapsed time. That is the time it takes from the completion of the previous activity to the completion of the current activity. The elapsed time is decomposed in the lag time and the duration. The lag time is the time between completion of the previous activity and the start of the current activity. It is decomposed in the transfer time, that is the time spent traveling from the previous processing step, the queue time, that is the delay between the upcoming activity being offered and it being allocated, and the wait time, that is the time between the upcoming activity being allocated and it being actually started. Please note that in our implementation, lag time also includes the time waiting for the resources. The duration is decomposed in the setup time, that is the time expended prior to performing the actual work, the processing time, that is the time actually spent doing the work, that is the one to remember as it is the most used value in BPSim. the validation time, that is the time spent inspecting the work done, and the rework time, that is the time spent correcting the work done. Only a few of these parameters are used in practice, but it might become useful to know it is possible to break down the time parameters. Let's illustrate the time parameters with an example. Within the pizza example, we could say the processing time to bake a pizza follows a triangular distribution with its minimum at 120 seconds, its mode at 170 seconds, and its maximum at 240 seconds. Let's now move to the cost parameters. These apply to activities and resources. They are composed of a fixed cost, which is fixed, as its name states, and a unit cost, which is a cost per unit of time spent by the activity doing something. The resource parameter describes what are the necessary resources to perform the activity. For example, to bake a pizza, the process needs two resources, a cook and an oven. The quantity for the resource can be specified, and the resource can be selected based on its name or its role. The control parameters are slightly different. On events such as start, it is possible to define an inter-trigger timer and a trigger count. For example, I can set a trigger count to 10 and an inter-trigger timer to 5. That means I will start the process every 5 units of time, 10 times. In our pizza delivery example, that would mean there are 10 pizza orders and each order is separated by 5 minutes. All these time values combined should not exceed the overall duration that has been set in the scenario. The inter-trigger timer could also be used to set a timer delay. So for example, an inter-trigger timer of 30 with a trigger count of 0 would mean to wait for 30 minutes. On control flows, such as gateways, it is possible to set a probability or a condition. For example, on an exclusive gateway, one of the branches could have a 75% probability to be executed and the other one 25%. When based on a condition, it can take the value true or false. To summarize, the possible input parameters in BPSim can define time, cost, resources required for an activity, as well as triggers for events and probabilities for control flows. BPSim also defines what results are requested from the simulation. So for each input parameters, we can ask for the minimum value, the maximum value, the average value, to count how many times an element has been executed, and also to sum up values. Results can be requested for the overall process, the time or the cost taken by the whole process, the inter-trigger timer between two instances of a process, or the trigger count of the whole process. In order to perform an activity, some specific resources might be required. Resource can be a human or an equipment. For example, to bake a pizza, the activity needs an oven and a chef. Resources are not defined in BPSim and are poorly defined in BPMN. Still, we can list some basic characteristics of the resources. A resource has a name, has one or several roles, and some quantities varying in time. In other words, each resource has its own agenda. As I said, this is not described in BPSim, but it has some impact on the simulation, because if a resource is required to achieve an activity and if the resource is not available, then the activity holds until the resource is available. This impacts the overall execution time of the process. Now that we have set up all the simulation parameters, it is time to launch a simulation. So the simulation is started on a specific scenario, and the scenario defines the absolute starting date of the simulation. The processes are started at this date and started again based on the inter-trigger timer and the trigger count. For each element in the model that has some BPSim information, a value is drawn from the statistical distribution that will drive the execution path on the gateways, adds up time and cost for the task. If a required resource is not available, execution will hold and the waiting time will be added to the execution time. If the intertrigger timer is short, it is not unusual to require a resource that is already being used by the previous processes. In that case, the simulation will demonstrate the resource is a bottleneck in a heavy load scenario. The scenario defines a number of replications, so the overall execution is executed a number of times. The difference between replications is the statistical distribution. The values drawn are different at each replication. Once the simulation is over, the results are also stored in a BPSim file, which might be confusing because the same BPSim file format contains the input and the output of the simulation, even though in practice they are stored in separate files. Please note the results are only the ones that have been requested, whether it is on execution time, cost or count. Since the simulation is based on statistical distributions, the results are also a statistical distribution over the different replications. Post-execution analysis of the results has to be processed to properly present the results. Let's now have a look at the BPSim file format in more details. First, it is based on XML, so it is pretty legible by a human. It is strongly related to BPMN as it adds the simulation information to an existing BPMN element. So the first lines we will read in a BPSim file are that it is XML based and the schema can be found on bpsim.org domain. The BPSim information can be added to BPMN description or it can be in a standalone file. To illustrate a real BPSim file, let's take this small BPMN as an example. There is a start symbol, an activity with a message output, and an event gateway. In the BPMN file, after the initial XML declarations, there is the overall process ID, which is SIM9. The process starts with a start event, which ID is SIM10. The order a pizza task with ID SIM11, and the event gateway with ID SIM12. Then the sequence flow that connects the start and the task, as well as the task and the event gateway. After the logical BPMN part comes the graphical description of the model. Let's add some BPSim information in this BPMN description. In the BPMN relationship tag, we use the BPSim data attribute to add the BPSim information. First, the scenario with its name, author, creation date, version, then the scenario parameters defining the base time unit, the number of replication, and the seed. And finally, the simulation scenario starting date. Then, for the first element of our process, which is the start symbol with ID SIM10, the intertrigger timer and count are defined. For the following elements, such as the order pizza task, the BPSim parameters are defined. In that example, the processing time is based on a triangular distribution with a minimum of 1, a maximum of 5, and a peak of 3 units of time. Here is now an example of a BPSim result file. One can recognize the scenario named bike delivery. The results are for the SIM40 element. First, the processing time for each replication, then the lag time for each replication. Here is a quick demonstration of defining BPSim parameters and reading the simulation results in our tool, PragmaDev process. We will use our basic demo example, the pizza delivery model that everybody understands.
So following up the theory, here comes a quick demo of BPSim. We have here the basic pizza example where you can see on the top a customer who is hungry and orders a pizza, then waits for the pizza, and when the pizza arrives, pays the pizza, gets the receipt and eats the pizza. If the pizza does not arrive after 30 minutes, he will call the pizza delivery restaurant and ask, what's going on, and we'll wait again. On the vendor side, the pizza side, we have three swim lanes, the clerk, the chef, and the delivery boy. So the clerk answers the phone, takes the order, and also if the customer complains after some time, he will calm the customer. Otherwise, or at the same time, I should say, it passes on the order to the chef who makes the pizza, and once the pizza is done, hands it to the delivery boy. So if we open this definition, we have a sub-process, so just to demonstrate how to make a sub-process here, there's no real point in that example. The delivery boy will get to the customer, get the money, and hand over the receipt. Okay, so that's the basic BPMN process we are looking at now. First thing, as we said during the presentation, we have to define scenarios. So here we have two scenarios, one called car delivery and the other one bike delivery. So the only difference in these resources is that we'll have people who deliver by bike or by car. You will find that the fields we described, you know, the version, the author, the creation date, and so on. And one of the key things here is the number of replications. You know, how many times are we going to repeat the overall process? Base time unit, base currency unit, and of course, on which diagram are we working on? And another thing is which resources are we going to use? So here we only have one team, so the team is over there, and I will open it up later. The car delivery scenario actually has the same information. There's no difference here. The difference will be in the BPSim values for some activities. Okay, so if I look at any activity there and I look at the simulation properties, the BPSim information is on that tab. You can see which scenario it's part of. So here we're in the bike delivery scenario, and we will put some basic time parameters. So it's just the processing time with a normal distribution with an average of 2 and a standard deviation of 1. And for each activity, we'll have some different information here. See, like make the pizza and so on. So in that case, whether it's the bike delivery or the car delivery, the information is the same. There is no difference yet. Now, if we go to the delivery itself, the difference is when you get to the customer. So when you get to the customer by bike, it will take longer. You can see like 15 minutes average than by car, but it will cost cheaper. So it's like 1 cent per unit of time and 15 average. If I look at the car delivery scenario, you see it's down to 10 for the time, but it's up to 10 cents for the cost. So that's why you have the difference between the two scenarios. Okay, that's the only part of the model here. Now, if I go back to the main process, there's another thing you need to define, is that whenever you do something, for example, you make the pizza, you want to say which resource I need. So in that case, I need a chef. In that case, I need a clerk. In the delivery pizza sub-process, I need the delivery guy. And these people are described in the resource file here, where I have, you see, 3 resources: a cook, a clerk, and a delivery guy. If I look at the quantities, look at the simple representation, I only have 1 cook, 1 clerk, and 2 delivery guys. So it's 1 person here, 1 here, and 2 here. I can deliver 2 pizzas at the same time. And last, we will define here what we want to see as a result during the simulation. So for example, the number of time I count the customer is a quality information I'm very interested in, because the more I have to count the customer, the worse is the quality. So I'll define here, I expect this as a result to count how many times I've been there. Okay, I don't do that everywhere. If I go here, you see there's no result expected. So it's important to see that we define what we expect as a result. Another thing is that we have a number of scenarios. So here, if I look at when I start the overall process, I will define a trigger count and an inter-trigger timer. So that means I will start this process 10 times, and each process will be separated by 10 units of time. And last, here you see I wait for 30 minutes before I call the pizza to ask where is my pizza. And the way to handle a delay, if you remember the presentation, is that we will set a trigger count of 0 or no value and a value of 30. And that means I'll wait 30 minutes here. Okay, now that we have set up everything, we can start a simulation. So you can see the two scenarios, the number of replications in each scenario, and we can go for it. So you can follow up what's going on. If there is any deadlock or timeout, it will display it here. But in that case, nothing goes wrong, so I can just save the results. And when I save the results, I will get here in this in the project manager a BPSim file, which is a standalone BPSim file that relies on the BPMN file. So if I open this, I actually reopen the same BPMN file, except that now I can look at each activity where I wanted some results. So for example, if you remember calm customers, I can see the simulation results. And I can see that, I can show the value here. I have the count here with the bike delivery in blue and the car delivery in green, and that the bike delivery is has a pretty bad result because I have to count the customer 320 times out of 1,000 times. So that's very bad because one time out of 3 I have to count the customer. Where by car is very low, it's only 64 out of 1,000. So in a way, it is better. Now, if I look at the parent process result, I did ask for the cost and the time. So the cost, of course, is much cheaper by bike than by car. But then the time, of course, is shorter by car, slightly shorter, not that much, and longer by bike. But that small difference makes a real difference on the overall quality of my delivery process. Of course, I have all the logs of the different scenarios. So if I want to replay one, I can just save it and replay it. So here I can generate the process, and I can replay it on the system step by step to further analyze what is going on. And last, we have also an analysis of the resources. You know how they are used. So, for example, you can see here the 2 delivery boys, the cook, and the clerk. And you can see the clerk is not that busy, actually. The cook is more busy, and the delivery guys are very busy. Another way to analyze how busy the different resources are is to look at the heat map of when the activity waits for the resource. So here you can see that, for example, this activity has been waiting 822, so it's a cumulative waiting time. so it's in red, so this is not good. We probably need another chef or another oven to speed things up. Okay, so just this was a short demonstration to show how you can define BPSim, and so that's the input of the simulation. Run a simulation, of course you need a tool to do that, and then you analyze the results you were expecting. And then, of course, it depends on the tool, what kind of presentation you will get in return, and the type of information you can analyze.
Okay, let's wrap it up now. Conclusion. With reference to a BPMN model, BPSim adds time and or cost based on statistical distributions. BPSim allows to define the input scenario and the expected results. Simulation handles the required resources. As a consequence, BPSim gives the necessary information to reduce the lead time, the cost, and to optimize resource allocation on a set of given scenarios. Thank you for watching. Please do not hesitate to like or comment. For more information, please visit our website, pragmadev.com. Please note there are other related videos, an introduction to BPMN video, which is tool agnostic, and two others that are tool demonstrations, one on Pragmadev process BPMN simulation with BPSim, and one on optimizing resources in a business process described with BPMN and BPSim. Thank you. Bye now.